Yeah. Comes on everyone. Let's start off. Did everyone try this problem? I sent a reminder in the afternoon also. I know some of you forgot. Now, Anusha, what did you get answer? Anika, Aryan, Abhinav, Niranjan, answers. Anyone got an answer? Anusha, no answer. Vastika, yeah. Abhinav, Aryan, Mehan, Yasha, answers. Ronak, Venkatesh, got something. I hope everyone tried, right? Gave it a try, na? Serious, like you spend some 20 minutes or something on this at least. Minimum. Okay. Sure, let's see how to do this thing then. Aditya, any answers? Tried? Forgot?
Yes, I tried it.
Tried. That's fine. Swastika, got something? Okay, let's. So, initially this is at rest. So initially the sphere was here. This was your state 1. This was your state 2. So from here to here, when it has fallen, this length is L. This length will be L cos 60, that is L by 2. And this length is also L by 2. Now at this instant, when it is falling, try to understand the velocities. This guy is going like this V1 and this guy is going with V2. Agreed? The ball will go in a circle, na, tangentially. The ball will go in a circle, whereas the wedge block will go in a horizontal direction. So loss in PE is equal to gain in kinetic energy. So loss in potential energy will be mg L by 2. The gain in kinetic energy will be half m V1 square plus half capital M V2 square. This is your equation 1. Everyone agrees with this statement here. Udayan, Neil. Then now see, just before losing contact, if you look at the velocities, velocity along the common normal must be same. So this is V1, this is V2. So if you take this angle is 60, this would be 60 and that will be 30. So this also will be 60. So velocity along the common normal must be same just before losing contact. Therefore, V1 cos 60 is equal to V2. So we get V1 by 2 is V2. This is equation 2. Do have a look at this, everyone. We are using rigid body constraints and we are using conservation of energy. So as long as they're touching, velocity along the normal is same. Just when you're about to lose contact, the velocity must still be same. Till here, most people get it, actually. People don't get the third equation. Third is a good one. Can someone tell me where will I get the third one from? Because if you see, there are actually 4 variables here: small m, capital M, V1 and V2. And I'm asking you small m by capital M ka ratio. So you can treat m by m as one variable only. So that means there are 3 variables: m by m, V1 and V2. So I need 3 equations to solve, but I only 2. One comes from energy conservation, one comes from velocity along the normal is same. Any idea where will I get the third one from? Any doubts on these two? Please ask me. The third one, yeah, fine. That is fine. Normal is 0, but you can't use that actually. There's one more thing there. Just before losing contact, acceleration is also same. Acceleration component along common normal must be same. So if you see, this guy has an acceleration 0 because you lost contact. There is no force. I'm exaggerating the figure. It's actually pretty close. This guy will have 2 accelerations: A centripetal, A tangential. And now you're saying this is the common normal. This is 60 degrees. This is 60. This is 30. So the horizontal component A tangential cos 30 minus A centripetal cos 60 should be equal to 0. To have a look at this. And we get A tangential from here. If you look at the forces, this is mg, this is 60, this is 60. This would be mg cos 60. This would be mg sin 60. This is A tangential. We end up with mg sin 60 is equal to m80. So A tangential is 0√3/2. So from here we get A tangential 0√3/2 cos 30 is √3/2. Centripetal is v1 square by L. Cos 60 is half. So we end up with v1 square is 3gL/4. अरे यार, I wrote wrong रे. ये 30 था. ये 60 था. √3/2 will cancel. You end up with Lg/2. This is your v1 square. This gives you the third equation. Please have a look at this. Yeah, Radrit, you're right. I messed it up. So basically, the acceleration along the common normal must be same. Acceleration along the velocity along the common normal must be same. And because you're losing contact, the wedge will have a capital M will have a 0 acceleration. So at that instant, when you just lose contact, the A tangential and A centripetal in the horizontal direction should cancel out. That is the main thing in this thing. It doesn't click most of the time. Have a look at this. It's a good one. Clear? Now we got everything. We can just solve. So energy conservation, mgl by 2, half mv1 square, half capital mv2 square. Second one, v1 is 2v2. The third one, v1 is root lg by 2. Substitute. mgl by 2, half mv1 square is lg by 2, plus half capital M v2 will be v1 square by 4. That will be lg by 2 by 4. mgl cancels everywhere, you get half. But hey, mgl cancel nahi hoga. gl will cancel everywhere, you get m by 2, m by 4 plus m by 16. So this will be m by 4 is equal to m by 16. M by m is equal to 1 by 4. That's your answer. By losing contact, no, not while losing contact, when it is about to lose contact. Once you lose contact, it's done. You can't compare with anything. It's always about like just before losing contact. So all these things, the velocity is just before losing contact. That's why I'm writing it just before losing contact. Because once you lose contact, both of them have no relation to each other. They'll go independent of each other. We don't have any information then. The solving part is easy. Please check the steps. Ask me anyway you're confused. Energy conservation, rigid body constraint. Rigid body constraint, there are two relations. One is the velocity along the normal and one is acceleration along the normal. Most people don't realize that acceleration part. Have a look at the steps. It's a good one. This will be a proper advanced paragraph. Yeah. Look at this page. The test card deadline is tonight. Make sure to give it. Some of you forgot, I'm sure. I understood by seeing your faces.
So in this, how do we know that the acceleration will also be the same along the common?
Because they're touching each other. Just
But
before
if,
losing contact, they're touching, right? Man,
Yeah.
the logical is ochna. If you're touching each other, if velocity and acceleration is not same, won't you lose contact?
yeah, but
If
if
your
the
velocity is same.
but if the velocity will be constant
Constant
along,
किसने बोला? I said velocity along the normal is same. When did I say constant? Did I say constant or did I say same? Velocity of the sphere and the wedge along the normal must be same, which is changing. Okay. All clear with this? Good one. Next one.
Can you go back for a minute?
This one.
Yes, sir. Thank you.
Yeah. Next one. We have a wedge. We have a block M. This is a smooth wedge, smooth hemisphere. This is a standard question. So if this is slightly disturbed, this will start moving here. Find the angle when it loses contact. Means it will come till somewhere here, and then it loses contact here. So this theta I want. The same question. What if this time the wedge is accelerating constantly? This time the block will go backward, right? So find theta when it loses contact. Get that. So initially you have a fixed smooth sphere, hemisphere, and there is a block on top of it. Someone gently disturbed it, so it starts sliding and falls off. That is the reason when you go to a kids ka park now, they'll never build a slide like this. You put a kid on top of this, kid will fly from here and will fly into the air. So that's why in kids ka park, the slides will be always this way. Someone must have realized it while building. No, getting the point. So you put a kid here, the kid will set, he will slide, and at this point he will lose contact, the kid will fly in the air. So find theta when the block loses contact with the hemisphere. Two cases. Case one, hemisphere is fixed, the block is gently pushed. Case two, the wedge is accelerating with A. So in this case, the block will go backward. So find theta when it loses contact. Get the standard equation. The first one is a standard one. Second one is a slight variation. Get the second part also, Aditya. Try. Everyone should try. Right, Adrit. How do we do this? Let me help with the first one. Why are you guys taking so long for the first one? See, when you see this question, right? It's not 60, right? I'll tell you what goes in my mind now. See, this is something which I want you guys to learn. Whenever you solve a question, try to understand what is happening. Try to get clues from the question. See, what did I say? If slightly disturbed, find theta when it loses contact. Okay. You're losing contact. So what is zero then? If you're losing contact, what is zero? Normal reaction, right? Now you think about, then you should think, okay, normal reaction is zero. Now tell me, in which chapter did you learn, about forces? Loss of motion. And what is the first thing you do in loss of motion? You draw an FBD. That is what should go in your head. Okay, मतलब FBD से start करना है. So you'll start with an FBD. And then you write the forces. Normal reaction. This is mg. So this is mg cos theta. Since it is going in a circle, there will be centrifugal force also mv square by r. And then you'll say n plus mv square by r is mg cos theta. And since you're losing contact, n is 0. Perfect. Then you get v square is equal to rg cos theta. Now you feel like, okay, that means I want to find velocity at this instant. Ah, yeah, sure, that is right. I want to find the velocity at this instant. Velocity is 0. Now, can you see some hint in this diagram only? You can see some hint in this diagram. When you see this diagram, can you see there is something called initial, there is something called final? You're interested between what is happening from here to here, means you're defining initial and final state. Where do we do that? Work power energy. You're getting it. You will be able to see those clues like, okay, I need to use work power energy to find velocity. So from here, so if this is r, this side will be r cos theta, and this side will be r into 1 minus cos theta. So loss in P is equal to gain in kinetic energy. So we get mg r 1 minus cos theta is equal to half mv square. And what is v square? mrg cos theta. mgr cancels off. You end up with cos theta as 2 by 3. And the best part, independent of radius. Means you take a big circle, you take a small circle, it doesn't matter. If it is a smooth surface, or everyone will lose contact at cos inverse 2 by 3. Check it out. Any doubts on this question? This is a standard one, meaning when I say standard, this is the kind of question which you'll get in exams like CET, BITS, luckily so maybe mains also. There's VIT exam, MIT exam. This will be like a standard question. You should know the result. Do the second part. What if this time the hemisphere is accelerating horizontally with it? You won't get a good answer. Answer will come in terms of phase. So just get the equations. I know the second will not be that great. But let's see whether you got the equations or not. I hope everyone is clear with the A part. Any doubts on this? Please ask me. Force equation, energy equation. Get the second, but you got a minute more. What if this time the wedge is being accelerated forward with a. Now, again, listen, there is a hint in this word only if you have observed this. The wedge is going with a constant acceleration. Then what should you do? Pseudo force. Remember, I told you this thing last time we did. Whenever something goes with constant, what are you supposed to do? In this question, remember? If something is going with constant speed, something is going with constant acceleration, we wrote. When any object or system goes with constant velocity acceleration, let the observer be on the system. Pseudo force lagana tha. You have all those hints and everything. If you revise your notes properly, you will be able to see stuff like this. And these things, what happens in the exam, you won't think, it comes by instinct. You see the question, you know what to do. That is when you actually get the real speed. You're thinking subconsciously so fast, you see the question and the steps are just coming out one after another. That is the state where you have to reach. And it happens a lot. People get into that state. At that point, you'll have a tremendous speed. So when the subject chapters are done, revision is done, and when you reach that state, you'll be better than me. That is the whole purpose. At least on the day of the exam, you have to be better than me. Second part. Something like that only you'll get Adrit. Right. One more minute. When's the major test? 28, na?
Yes, sir.
This is the second part. Initially, the block is here. This is theta. The pseudo force will be backward. So your observer is standing on this thing. Pseudo force is backward. So what are the forces acting on the system? Normal reaction, mg cos theta, the centrifugal force, and this pseudo force का भी component आएगा. This is 90 minus theta, so we get pseudo force का component also. M is sin theta. The forces along the normal n plus mv square by r plus ma sin theta will be equal to mg cos theta. Normal reaction is 0. Now, when you're conserving energy, this distance is r into 1 minus cos theta, whereas this distance is r sin theta. So work done by external plus work done by pseudo force will be the change in energy, E final minus E initial. Work done by external force is 0. The pseudo force ka work done is ma into the horizontal distance r sin theta. I hope you remember that. If the force is horizontal, you have to take the horizontal displacement. The final energy, I'll take the initial as a reference line, minus mg r1 minus cos theta, potential energy, plus half mv square, whereas the initial energy is 0. I'll take this as a reference line, potential 0, and I take 0. So this guy would be, m will cancel, er sin theta plus gr1 minus cos theta is v square 2 times. This is quite long. This is your equation 1, this is equation 2. So take this v square and substitute there. You end up with v square by r to 2a sin theta 2g1 minus cos theta plus a sin theta is equal to g cos theta. Bring all sin thetas to one side. This is 2g. Did I get it right? Yeah. Check it out, something of this sort. Basically, you have to take this v square from here and put it back in that equation. You can leave it there. Numbers are given, you'll get the answer. But that's how you solve it. So here, while drawing an FBD, you have to take pseudo force ka component, and while taking work done, you have to take pseudo force ka work done. Any steps you're not clear, please ask everyone. Clear? Can I go ahead? Mehan? Swastika, clear with this? Ali? Understood? Maulika, Palaksh, Vidyut, Anika, got this thing. Venkatesh, clear with this? Venkatesh, to adjust your camera, I can't see you. Which is better, work theorem or conservation? But if you see, Adrit, work energy theorem is more powerful, right? Conservation works only when there's no work done, right? If you see it that way, work energy theorem is more powerful. It always works. Energy theorem doesn't work, meaning this conservation of energy doesn't work every time. Where is this problem? I said one case we got. I'll find the problem. Wait, how did we get E final? E final is this point, no? Potential energy is like minus mgr 1 minus cos theta, and kinetic energy is half mv square. How then? Sure. Yeah. Next one. This is a good one, right? We have a like this. We have a semicircular pipe. So inside we have two balls. Again, I'm exaggerating the figure here. Small m and small m. Both are released from rest. So what happens? And the balls are loosely fitted inside. And you can neglect the dimension. So basically, you can think of this as R. Meaning ये distance जो है ना ये negligible था. It is very small. Balls are very small. Just to understand, I drawed a big diagram. Now, what happens here? Just now we solved that at an angle cos inverse 2 by 3, the balls will lose contact. But in this case, because it is a pipe, what will happen? When they're falling down, they'll start touching the outer surface. So the question is, as this both the spheres are coming on both the sides, find alpha when the semicircular pipe lifts off the ground. Find the maximum value of m by m if it lifts off. Means there is a certain value of m by m. If you exceed that, no matter what you do, this thing won't get up, won't rise over the ground. First, you need to understand why the hell this is getting up actually. Meaning, कैसा होगा पता है diagram? Again, I'm kind of exaggerating it. This thing is a lifts off the ground, and the spears are like this. You're getting this whole setup actually lifts off the ground. Just to give an idea what is happening, I'll tell you. See, the centrifugal force is there, na, mv square by r and mv square by r. Uska vertical components are lifting the weight. Getting why this thing lifts off? As they're coming down, they will touch the outer side of the pipe. The centrifugal forces are pushing the pipe outward, so the pipe lifts off. This is how the diagram looks here. So the normal reaction becomes, it just loses contact. So the question is find alpha when this thing loses contact. Get this. Anyone didn't understand the question, please ask. Question is clear. Go ahead. You got 3 minutes, 4 minutes of the first part. The question should be clear. Someone, what is happening with the question asked? You understood what is happening, don't know how to solve, that's fine. Keep trying. Got 3, 4 minutes. Cos theta mg y. Okay. What about the second one? Get the second part. If this was a paragraph question, these will be 2 questions in that.
With the alpha
Yeah.
dependent by m ratio.
Yeah, it depends on m by m. Answer capital M small m terms में आएगा. Answer of second part is what? Didn't type the answer, Anisha. Cos alpha 4m by 6m plus n2. Near Anisha, that's not the answer. वो first part तो इतना, you won't get such a good answer, but yeah. Root m by 2mr. Adrit, see, why your answer is a blunder. Like I said, you don't know what is right, but you can tell which is a blunder. Cos alpha, you wrote m by 2m into r. Dimensions are not matching, isn't it? Cos alpha should be dimensionless. Dimensionless. You are getting a dimension of 1 by length. mgr by 2mv square. Okay, let's see. People are getting weird answers. So first thing, let's see exactly little explanation what is happening exactly here. So we know so initially if you look at the sphere, it is touching the up to this angle where cos inverse 2 by 3. So initially the ball is touching the lower surface here. Then the ball touches the upper surface. So up to theta, which is cos inverse 2 by 3, the ball touches the lower surface. And after that, it touches the outer surface. And outer surface matlab the upper surface. So at this instant, if you see the centrifugal forces here, which we get mv square by r, and the centrifugal force mv square by r, those guys are balancing this weight capital mg. That's why it lifts off. You're getting? This is the reason why it lifts off. Understood? So when you throw the ball, it will touch the lower on the lower part, then it will go and hit the upper part, and it will slide on the upper part. So let's draw the FBD, when it is just losing contact here. So this is the instant when it is losing the contact. If you write the forces, we have small mg, right? And
So your voice has become very faint.
Yes, sir.
Yes, sir.
any better now? No.
No, sir.
Sir, can
Good,
barely
sir.
hear you.
How is it now?
It's still the same.
Now is it better?
Yes, sir. Now it's
Yes,
loud.
sir, now.
Yes, sir. we can
I
hear
brought
you.
a new headphones also, right? For this sake. Let me see. Now any better?
Yes, sir. Now
Yes,
it's
sir.
good.
So I just restarted it. Yesterday I brought a new one. If you guys say I throw the double also in the morning, I can't return it. Let's see. So yeah. So let's draw the FBD of each one. Okay. So let's say this angle alpha, it lifts off. Semicircular thing lifts off. So let's draw FBD of the ball. On the ball, normal will be this way because it's touching the outer surface. Then mg ka component will be this way. Mg cos alpha. Centrifugal force will be outside mv square by r. This is alpha, okay? So this is the mg cos alpha component. So from here, I can get n is equal to mv square by r minus mg cos alpha. This is equation 1. Check. Then, now you draw FBD of the semicircle thing. semicircular one. So on this semicircular one, the same normal reactions will act like this. This is N. This is N. And this whole weight will be capital Mg. This is alpha and this is alpha. So we get 2n cos alpha is equal to capital Mg. And what is n? 2 mv square by r minus mg cos alpha. We'll keep it like this. This is the second equation. Check. And second thing, we can conserve energy also. So from here to here, this height will be r into 1 minus cos alpha. So loss in PE is equal to gain in kinetic energy. So that would be mg r 1 minus cos alpha 2 times, because there are 2 of them, is equal to r of mv square into 2 of them. So we get v square is equal to 2gr 1 minus cos alpha. This is your equation 3. Please check the 3 equations. Energy conservation, FBD of the ball, and this thing. I have a doubt here. Why can't I just write like this? I can take this thing as centrifugal force mv square by r. Centrifugal force mv square by r. I'll take the total weight m plus 2m into g. I'll take centrifugal force ka vertical components 2 mv square by r. Cos alpha is m plus 2m into g. Can I do this? Can I do this? So basically I'm taking FBD of the balls plus the semicircle. This is a blunder. Getting it? You can't do this. Can someone tell me why?
So is it because they are moving with different velocities and all?
Yeah, the balls, right? They have acceleration now. Unka tangential
Yeah.
acceleration hai. The semicircle is not moving, but the balls inside are accelerating now. There is a tangential acceleration. Getting it? We can't equate them. This is wrong, basically. Since the balls have a vertical acceleration. What did you assume here? You assume system is at rest. You took the net force is equal to total mass is at rest. But the balls are having acceleration in the vertical direction. So you didn't taken that into account. And second thing, if you remember in NLM, we wrote a statement there. You can treat two bodies as one system if they have same acceleration. Here they don't have same acceleration. The alpha angle is same and the velocities are the same. Velocities will be same. No, I'm not talking about that. This sphere here is having an acceleration in the vertical direction. No? This sphere is also having acceleration in the vertical direction. There are accelerations in the vertical direction. Right, Anika? But when you wrote this equation, you know what you assumed? You assumed as if the balls are fixed here. Isn't that the meaning of that equation there? You assume the balls are fixed there in the air and they're not falling down. Clear? So be careful that you can't do this thing. If you have done this, it is blunder. You have to write FBD separately for both of them. This implies, you know what? This implies the balls are at rest. This is what I was keep saying, you know, it's not only about getting the right thing. You should know what kind of goof ups you can do. You have to write them separately. You can't take them together as one system. They don't have same acceleration. The semicircle is at rest and the balls are accelerating downward. Please check the equations. Can you solve them? Actually, you got the answer from here. Try, I'll give you a minute or two. I hope you guys like. How many of you did this thing? You took the net force. Okay. Try. Now you solve this thing. But please check the 2 FBDs and 1 energy equation there. Cos inverse 1/3. You're such a beautiful answer, right? M and capital M cancel कर लिया तूने. So let me write the equations down. N is mv square by r minus mg cos alpha. 2n cos alpha is capital Mg. B square is 2gr 1 minus cos alpha. So dump mv square by here. So this guy will be 2mg 1 minus cos alpha minus mg cos alpha. And will be 2mg mg 2 minus 3 cos alpha. Take this and put it in this. 2 mg 2 minus 3 cos alpha. Cos alpha is capital Mg. Gg cancels. We end up with 4m minus 6m cos square alpha. 4m cos alpha is equal to capital M. 6m cos square alpha minus 4m cos alpha plus m is equal to 0. We got a quadratic. So cos alpha will be 4 small m plus minus root over b square, that is 16m square, minus 24m small m by 12m. This will be the angles, everyone. Now, if you got this, you get the second part from here. For a cos alpha to be real, the discriminant should be greater than 0. Delta should be greater than equal to 0. What is delta here? 16m square minus 24 capital M small m is greater than equal to 0. 1 m will cancel. We end up with m is greater than equal to 3m by 2. Or you can write m by small m should be less than equal to 2 by 3. So the maximum value is 2 by 3. That's the ratio. The roots have to be real. So if you actually get the first part, you get the second part from there. So if the value exceeds 2 by 3, do whatever you want, the sphere will never lift off. That is the meaning of that statement. If m by m is greater than 2 by 3, the semicircle will never lift off the ground. Please check. This is a good one.
Can you show the previous page to this for a second?
This one.
So the one after this. Yeah, so thank you.
Do check. It's a good one, huh? This one and that homework problem, these are pretty good ones. This is how will they'll frame you advanced may paragraph questions. Clear with this? Any
Sir,
doubts?
if the
Arjun.
mass of the pipe is less than the mass of the two balls, then
Mhm.
how is it balancing the balls in the initial position?
Why? Matlab, you have a weighing machine. If you go and stand on the weighing machine, should the
Oh,
weighing
right.
machine be
Uh-huh.
more heavier than you?
Yeah, yeah. Okay.
Clear with this, everyone? Can I go to the next one? Malika, Neil? Neil, I can't see you. You're not there. Neil is sleeping. Neil, are you there? Seriously, he's not there. Okay, let's see. Next one. We'll kick him out now after this question. Let's get this. Neil, are you there? Once. Neil, are you there? Twice. Neil, are you there? Thrice. Bye. He's not there. We called up 3 times, huh? So let's get this thing. You have to use washroom something, just leave a message and go. No props. But if you vanish like this, we have to assume you're eating food secretly. And I do have a blueberry cheesecake in my refrigerator today, which I was planning to eat after the class. So let's get this thing. Read the question. It's a good one again. You want, these kind of weird, tough level questions, right? You should definitely do level 5 and level 6 of my booklet. But again, your priority should be to always finish off. If you're doing your PACE booklet, LN booklet, what you're doing, finish your booklet properly. Don't run behind, like all these big, tough questions. Because no matter how tough the advanced paper is, right? If there are 20 questions in the advanced paper, you will find at least, 10 to, at least 10 questions which are easy to moderate things. So your job is to first to get them right. And uske upar, if we can do at least 3-4 tough questions, right? That will give you a very good rank. But in the pursuit of doing all these tough questions, you mess up the basic ones also. There is no point in that. And your friends will like to show off. अरे पता है मैंने Cengage complete किया, पता है मैंने वो book किया, ये book किया. Let them go to hell. Don't fall into the trap. That's a big trap. Your job is like, okay, I'm comfortable with my topic. See, what is confidence? If I tell you I'm going to give you 10 questions from circular motion, without even seeing the question, you should tell me, sir, I can do at least 7. You're getting right now. If I challenge you, I'll give you 10 questions from circular motion. Can you do? You should be able to tell me confidently, sir, I think I can do up to 7. If you have that kind of blind confidence, meaning you are confident on it. I'll tell you, right? I solved HC Verma 3 times. I didn't do, maybe Erido, I did a little bit, but our subject and our concepts are much stronger at that point of time. And we used to write subject to exam, right? Object to nahi tha. It is just not marking something. That is because every question we used to do, we used to have a deep analysis. Okay, aisa ho raha hai, aisa bhi ho sakta hai, aisa kyun ho raha hai. Did you see every question that I teach you? I just don't stop with like, do like this and it is done. We even try to analyze like, how to think about this, what can go wrong in this, what kind of misconceptions we do. This is what will make your subject strong. It is not blindly doing some multiple questions without understanding any head and tail. Try this thing. This is a good one. This is a tricky one. This is a question which is tough but easy to solve. So never get confused between a lengthy question and a tough question. Both are different. Oh, seriously, this Neil is still not there, right? Try. Think for a minute more, then I'll show you. So just to give you a scenario, remember this is a graph, okay? This is a graph. On a rough horizontal surface, coefficient of friction is not uniform. Fair enough. A small disk is projected with speed 5, which stops after covering 8 meters on the surface. So something like this. So this was x is 0. This was x is equal to 8. So when you gave a speed of 5 meter per second, this block was sliding and finally it stops here. Yeah, data tha. Variation of the speed is given, blah, blah, blah. Now the question is, what if a project only with 4? How much will it travel? If a project with 5, you would have traveled 8 meters. If a project with 4, what would have happened? Now from this one conclusion we can make, work done by frictional force is change in kinetic energy. That will be 0 minus half m5 square. Mass का जरूरत नहीं है. So yeah, so that will be minus. This is the value. This much I know. Now I don't know what is the value there exactly, but this much we know. So this is the work done by friction when you go from 0 to 5. The question if you're throwing,
0 to 8 x.
yeah, 0 to 8. Sorry. Try. Just give it a try. Just get some water and come.
Let's see. So let's see. Can you guys hear me? Able to hear me, right? Okay. Not able to hear me? Can you hear me? No, sir, it's very, very faint.
Now?
Yeah, now we can hear you.
I think if I just keep this thing aside for 10-20 seconds, this thing stops, I guess. Let's see. Now 6 meters. No, that's not the answer. What? Like, we kind of have to manipulate the data here. So I know work done by friction, is this thing. So you're saying, what if I project with 4 meter per second? So can I write like this? So half m 4 square can be written as half m 5 square minus half m 3 square. Isn't it? So what is this? This is the change in kinetic energy when your speed becomes 5 to 3. So half m 4 square. So if you give with a speed of 4, now this is change in kinetic energy when speed becomes 5 meter per second to 3 meters per second. Now go to the graph. Where is 5 meter per second? Initial point. Where is 3 meters per second? This point. Means when you're at 5, you are at 0. When you're at 3, you're at 4. Means you traveled how much distance? 4 meters, no? You're getting it? At this is x is equal to 0. This is x is equal to 4. Therefore, particle travel from 0 to 4. Easy. You're getting the logic there. So half m 4 square is 5 square minus 3 square. So this is change in kinetic energy of the particle when the speed has gone from 5 to 3. So your 5 meter per second is x is equal to 0. Your 3 meter per second when you are at 4 meters. Means when you go from 0 to 4 meters, your speed has become from 5 to 3. That means you must have traveled 4 meters. Easy. That's what I said. This is a tough question, but easy to solve. If you can manipulate that and figure it out. That is the hard part to think. Solving is actually easy. So at this point, the speed is 3 meters per second. I don't know exactly what is friction, anything I don't need. But main ye hai, the question should always start, you should always start with 5. The catch is that. At x is equal to 0, 5 speed 5 hona chahiye. So no matter what speed you give, I will always manipulate to get 5 at the x is equal to 0. Is this clear, everyone? Check it out. It's a good one. Anyone not convinced with this, please ask me. Clear? Next one. Sina, you're saying you're projecting with 4 meters per second. So I can write 4 square as 5 square minus 3 square. That you understood. So now look at this thing now. Half m 4 square is what? Finally, you will stop somewhere, isn't it? Half m 4 square is half m 0 square. So change in kinetic energy when you go from 4 to 0 is as good as change in kinetic energy when you go from 5 to 3. Right, Anusha? That means if you give the block a speed of 5 meters per second, right? And when you reach a speed of 3, whatever you would have traveled when you go from 4 to 0. Make sense? Everyone clear with this? Ronak, Rehan, Udian? Sure? Vartika? Clear, na? Aryan? Adrit? Yasha? Clear, na? Perfect. Next one. Vertical circular motion. Now, what is this thing? So consider a mass m. Pendulum of length L and mass m. Right? Free to move in a vertical plane. So this is fixed here. This is going with speed u. This is length L. We are taking this to be a string. So now when you project this, if you look in the lower hemisphere, or you can say the lower quadrants, if you draw the FPD in the lower hemisphere, this is what you will see. We have tension. If you take this as theta, we have mg cos theta. And we have centrifugal force, mv square by r. Meaning you can do anything you want, but the tension will never be zero. T is always mg cos theta plus mv square by r. String never becomes loose in the lower quadrant. In the lower hemisphere, tension can never become zero. This problem occurs at the upper hemisphere. Now, so in upper hemisphere, now if you draw the FBD like this, so initially the pendulum was like this. Now look at this. This is the main catch in this problem here. This is theta. If you draw the forces now, we have tension, we have mg sine theta, and we have the centrifugal force mv square by r. So we have T is equal to mv square by r minus mg sine theta. So there is a possibility of tension becoming zero here. Now, as the particle goes up, so here the one person who is trying to keep you tight is the centrifugal force. But as the particle goes up, the speed decreases. Therefore, if you see mv square by r is decreasing, the one who is actually helping you is decreasing. So it's like the good guy is becoming weak, and the mg sine theta is actually trying to make the string loose is becoming strong. A typical plot in our movies. You're getting it? So the hero starts becoming weaker and the villain is becoming stronger. So at some point, what will happen? There is a chance, the string becomes loose. But if you want to complete the circle, the worst case scenario is where at the highest point. At highest point, if mv square by r can somehow, mv square by r is the weakest and mg sine theta is strongest. So think about it. So at the highest point, if the mv square by r can balance mg sine theta, then you'll complete a circle, isn't it? If you can somehow balance at the highest point, then no matter where you are, string can never become, loose. Have a look at this page. I will show it in the next page in more detail.
So can you go back for a second?
Hmm.
Yes, sir, thank you. Yes, we're done.
Then, let's see. So at the highest point, if you can keep the block safe from falling down, then you are safe everywhere. We have tension, we have mg, and we have the centrifugal force mhp square by L. Just give me a minute. Someone is ringing the bell. Yeah. So at the highest point, right, the VH is the minimum and the mg sin theta is the maximum.
The voice is gone soft.
I need to do something about this thing. Yeah. So कुछ तो है thing. I need to do some app का setting for this thing. So at the highest point here, you have the speed as VH here. So if you write the equation, tension plus mg is mvh square by L. The mvh square by L minus mg, this should be greater than equal to 0. So velocity at the highest point should be greater than equal to root GL. This is the important thing. You're getting it? You need to have at least a velocity of root GL at the highest point, or else the tension will become 0. So if you take this point speed u here, this is your state 1, this is your state 2. Potential energy, 0. Kinetic energy, half mu square. At the highest point, potential energy is mg, 2L. Kinetic energy, half mvh square. So if you conserve energy here, energy in state 1 is equal to energy in state 2. So we are taking the minimum case. Then this will be half mu square is equal to half mvh square plus 2mgl. M cancels off. U square is equal to vh square is gl plus 4gl. We get u is equal to root 5gl. This is your minimum speed you need to complete a circle. So u should be greater than equal to root 5gl to complete a vertical circle. This is a standard result. If you don't give at least this much speed, it will not complete a circle. It will become loose somewhere in the middle only. Have a look at this. So generally we have this feeling, right? At the highest point, velocity should be 0. That is not true.
If the
Look at
velocity
this.
was 0, then it would have just dropped down in a straight line.
It wouldn't have gone till there also, meaning this is what would have happened. Let's say if your velocity v is less than root 5gl, this was a circle, no? The motion would have been like this. It would have gone here till somewhere here, and then it would have become like this. The string would have become loose. It would have fallen even before
Right, yeah.
reaching the highest point only. Getting it? This would have the motion. So at this point, somewhere here, tension becomes 0. So if I'll turn the page, if u is less than root 5gl, again remember this is a string. If u is less than root 5gl, the string becomes slack somewhere in the upper hemisphere and it goes like a projectile. This would be a parabola. Clear? So you have to give at least root 5 GL. If you give more, that is fine. If you give anything less, you will fly off. Do check it out. Clear, everyone? Any doubts on this? Next thing. Can I turn the page, everyone? Then so at the highest point, if you're giving speed u, where u is greater than equal to root 5 GL, minimum this much speed you should give. When you come to the horizontal position, the speed is root over u square minus 2 GL. This thing just comes from conservation of energy. At the highest point, the speed is root over u square minus 4 GL. So if you look at the string here, this is the tension at the highest point, and T1 is the tension at the lowest point. This is what you'll observe. At highest point, the forces are T2. This will be M u square minus 4GL by L, and this is mg. At the lowest point, tension is T1. This is mg, and this is mu square by L. When you write the equations and subtract, you will get T1 minus T2 is 6 mg. This is valid enough as long as u is greater than 0. This will be a straightforward question in bits or CET. CET में तो direct result है. In a vertical circular motion, the difference in tension between the lowest and the highest point is what? 6 mg. For any value of u. The difference. You can check it out from these equations here. You can find T2, T1 and subtract them. You'll always get u square will get cancelled. Clear? Next one. Suppose if you replace the string with a rod, then what's the difference here? At the highest point, you can have V0 because the rod can push and pull. Unlike a string which becomes slack, since rod can push and pull, at highest point, we can have tension 0. In this case, we get U minimum is root 4 GL. Be careful, rod and string results are different. Do check it out. Clear, everyone? What is the deal with the root 2 GL vertical circle? Which one you're talking about, Aryan? String one, where is root 2 GL? Nothing. I'm just showing you nothing much. There's no as such big deal about it. Clear? Let's see a question. Any doubts so far? Please ask me. That is the concept about vertical motion. Root 2 GL, root 5 GL. I am not sure what is root 2 GL though. Root GL is at the highest point. So root 5 GL though is fine. I don't know what is root 2 GL though. Clear? Next one. Let's do a simple one. We have a track like this. You must have played in Hot Wheels, the car ka thing. So here we have a sphere. This is the smooth track. And this height is h. And this radius is r. So the first question is, find h minimum if particle completes a vertical circle. That's an easy one. The second part, if h is 2 times h minimum, find acceleration at point A. Let's get this thing. So we have a smooth circular track of radius r. The height is, we are leaving a ball from height h. So basically this guy will roll like this, complete a circle like this. So when you go to this Imagica or something, no, this is how they design actually. You go to the highest point and then when you leave it, you just roll it down. So some guy in Europe, no, long back, they came up with an idea. They said, why don't we design something like this? 7 circles. The total ride would be around a minute. You'll be in the circle. So it was just a theoretical thing. After making it, right, you're running through different simulations and these people realized the 7 circles, right, the time span is so long, the brain will be deprived of oxygen. So people die when they come out. This is a death ride. If you can send people here and you get dead bodies from here. So this was never built. Getting it? This is a very bad ride. So you can't have so many circles. So normally if you see, maximum you have one and then you get a gap and then maybe you have one more or you'll have it in some other rotation. So making 7 non-stop consecutive circles, right? You're going so fast, you will be deprived of, the high speed will be very high. Just to show you here, at the lowest point, if you leave from height h, your speed will be something like root 2 gh. Your acceleration will be mg plus mv square by r. You get a very high acceleration. Normally in the roller coaster rides, if you see, I'm sure everyone went to Magica, right? If you see the rides, this is how it is seen. The ride is like something like this. There are some rides like this actually. So you will observe this time, next time if you go, hear this thing. When people are coming on that roller coaster, people are like, meaning there's a break. If you take a ride like this, you will hear the voice suddenly goes off. Observe that next time. If you have a ride like this, as the people are falling down, they'll shout all and then they just stop for a moment. Then again it comes The reason at the lowest point, the acceleration rate exceeds gravity. You almost experience 3 to 4 times the gravity. Means at that point, your body weight is almost 3 to 4 times. The force is so high, even though it happens for a very fraction of a second, the air in your lungs is pushed out. And if there is no air, you can't shout. You're getting, it is not that everyone decides, yeah, lowest point mein koi chillayega nahi, everyone is silent. People are trying to shout, it just doesn't happen. And the best part is your brain doesn't register that is not getting oxygen. It happens so fast, your brain doesn't register. So when it suddenly the oxygen supply gets cut off, the brain will start thinking, oh shit, I'm dying. Let's release some adrenaline and and all these hormones to make you ready for a fight. And tujhe lagta hai, yo, yeah, this is excitement. Brain is thinking, shit, I'm dying, and you think it is excitement. That's the difference. So
So what
yeah.
are the maximum number of circles you can have so that people don't die?
That I think no one has researched it, but I think you can go up to 2 to 3, I guess. But still you'll faint though. Means you are asking on the verge of people not dying. So it means it is acceptable for people to faint.
So what if the size of circles are reduced? I mean, the radius decreases.
Then it is even more deadly, right? V square by R, you're making R smaller, then you're getting even more accelerations. You'll get crushed. You should actually have a bigger radius so that you're actually safe. Smaller circles will actually kill you faster. It looks more exciting, but yeah, things go wrong, it will be pretty deadly. Right, Aryan? Get the second part. So this is what happens, when they train astronauts, right, or these Air Force pilots, they're kept in a kind of a centrifuge and they're rotated. They train them for this thing. Normally, Air Force pilots are trained to withstand up to 6 to 7G. 6 to 7G they can withstand again for some time, and they wear some special suits. Movie जैसा नहीं है. हमारे movies में तो hero directly gets into the plane and starts going off. The first thing that will happen, he will faint, and the plane will crash and will die. Movie gets over there. It looks very bakwas, so they don't do that. Salman Khan will go at supersonic also. कुछ भी करेगा वो. So only in movies it happens. Without training, nothing. You get into the flight and you ride it like scooty, or yes, you are riding something like that. These people are trained for countless hours, in that simulators and in that centrifuges to withstand such kind of accelerations. This astronauts, when they go into the space, all of them faint. All of them faint. The acceleration rate exceeds like 7 to 8G while the vertical takeoff. These people are in a sleeping position. All of them faint. Simple reason why they faint also. See what happens. When you're in a sleeping position and you're accelerating with such a high value of G, all your blood, right, starts accumulating at the bottom part. The front part of the brain does not get any blood supply. So from the frontal lobe, right, the blood actually recedes backward. So once you don't get blood supply, you go unconscious. You're lost. For at least, few minutes, these people are unconscious. And so once the space shuttle reaches into the outer space, once the acceleration decreases, the blood flow will come back. Someone will wake up first. And that guy will go and just wake up everyone. And that means while a space shuttle launch, something goes wrong and it explodes and people die. These people don't even realize, there is an explosion. They'll just die in sleep. Unfortunate, but it's kind of a peaceful death. But yeah. First part is 5/2R, yeah. See the first part. So this is simple. So when you want to complete a vertical circle, just now we proved at this point, the speed should be at least root 5GL. So the speed is at least root 5, minimum is 5GR. You will complete a circle. We can use a result. So state 1, potential energy is 0. Sorry, potential energy is mgh. Kinetic energy is 0. State 2, potential energy is 0. Kinetic energy is half mv square. This would be 5 mgr by 2. So energy in state 1 is equal to energy in state 2. So all humans, right, in any vehicle which is going fast, they experience this thing. These F1 race car drivers, go and check it out, their photographs. You will find they have very thick necks. if you compare an average human ka neck and if you compare an F1 race car driver ka neck, they're like pretty thick. Matlab, maybe I think around 15-20% thicker. Because when you're going in the car and you're taking turns at such a high acceleration, the heads are actually literally getting bent to withstand such kind of this thing, right? Their necks have to be very thick, or else they'll get this neck injuries and spinal cord injuries. So these people actually train necks in the gym in order to withstand those kind of G forces. So check it out, F1 race cars, and see these people are training for years. So eventually the necks become quite thick. Their necks look quite different from normal humans. This guy will be 5 mgr by 2. So this gives you the H minimum 5r by 2. You need at least 5r by 2 to complete a circle. Clear? Now the second question is, you are giving 2 times of this. Find the acceleration at point A. Let's get this finished off. If you're giving 2 times the minimum value, find the acceleration at point A. A is making 30 degrees here. Root 17 RG. Okay, let's see. Try others. It's a good one. There's not actually vertical circular motion. It is more of a work power energy and circular motion though. We'll wrap up the chapter next class. Friday we'll wrap up work power energy. What are they doing in PACE right now? They started ray optics or center of mass collisions?
So both.
Very optical for track 2 and
For power.
passes,
They started anything new chapter other than work power energy or nothing?
Cool, sir, but they'll start tomorrow center of mass, and on Saturday they'll start ray optics.
Okay. ठीक है.
So we started both.
चलेगा. We'll start one of them. I'll let you know next week, and then we will see ray optics. They will do work power energy only because major test hai na. They will not last week. Generally, they don't teach. Generally. And anyway, they rushed your seniors ka portion and finished it off last month. Now the teachers are free. I think for you guys only they rushed the portion for seniors. What is the second word, everyone? Someone got root 17 RG. Let's see. So at this point here, when this ball is here, it will have 2 accelerations. A centripetal, A tangential. So the resultant is A centripetal in this thing. And what is this height here? This height is R sine theta. So this total height will be 3R by 2. And you're saying H minimum will be 5R. 2 times now. So loss in potential and just gain in kinetic energy. That would be 5R minus 3R by 2 mg. 5R minus 3R by 2 is half mv square. 5 to 10 minus 3, 7 gr ka root. This is the velocity at point A, everyone. So from here we get A centripetal is VA square by R. This will be 7g. And what about A tangential? So at that point, if you draw the free body diagram, This is 30. This is mg. So this is mg sine 30. This will be mg cos 30. Will be A tangential. So we get A tangential is equal to g cos 30, which is g root 3 by 2. Numbers are not that great. So what's the net acceleration? So A net will be root over A centripetal square plus A tangential square. This guy will be 49g square plus 3g by 4. Numbers are not bad. I do it in my 3. Check my calculations. Did I do it right or did I go up somewhere? G to bahar aa jayega by 2 root over, how much is this? 49 fourths to 199. Such a weird number though. Tick. So main catch is that most people will find centripetal. They'll forget tangential part. The question is find the acceleration of the ball. So you're asking that acceleration. Please check. Any doubts on this? Please ask. Clear, everyone? Any doubts on this? Please ask me. Last one for the day. This is fixed. This is the string length L. This is a mass M. So it is released from rest. Pendulum is released from horizontal position. So just below this fixed point, someone kept a nail here. At a distance x. So what happens when you leave this pendulum here, this will swing. And when it hits the nail, it starts rotating about the nail here. You're getting how it is? What about g sine theta? That g sine theta normal relation will take care of centripetal acceleration, no? Huh, Anisha? N and mg sine theta is m into a centripetal, isn't it? The resultant of n and mg sine theta will take care of it. So this is what happens actually. So the pendulum hits the nail and completes a circle about the nail. Find x. So what is the meaning of this? See, suppose if you keep the nail too close, what will happen? This will swing. This part will hit this part here and it will swing like this, na? You're getting? It won't complete a circle. So if you keep it too low, This will hit the nail. So this is fixed here. Then this will go in a circle like this. You're getting the point? So if you keep the nail too high, there is a chance it won't complete a circle. It will just swing and will go back again. So this motion would be something like this. It will go till here. So this is how the entire motion will look. It will go from here to here and then will come back again. It won't complete a circle. So the question is find x if it completes a vertical circle about the nail. Finish off, easy one. Yeah, right, Adrit. Now I was saying if the nail was too high, meaning too close to the fixed point, it won't complete a circle. It will just swing like this and come back. So you need to keep the nail at a certain lower position so that it will complete like this. It will go around the nail. Clear? The question was find x. 5/2. I didn't think 5/2 means you'll go out of the string, right? See, this was fixed. So when you come till here, at this point, the speed is v. This is state 1 and this is state 2. So loss in potential energy, mgl is equal to half mv square. So we have a speed is equal to root 2 gl. So now you're saying you kept the nail somewhere here and you want this guy to go in a circle about the nail. So for this circle, what is the radius? L minus x, agreed? Makes sense? The radius of this circle will be L minus x because this was x and that is L minus x. So remember the result, if the velocity is greater than equal to root 5 gr, you will go in a circle. What is the velocity? Root 2 gl. So basically here you're changing the radius of this 5g, it will be L minus x. 2l will be 5l minus 5x. We get 5x should be greater than equal to 3l by 5. So your answer should be x should be less than l, but greater than 3l by 5. As long as the nail is placed in this position, it will always complete a vertical circle. All clear with this? Clear, everyone? Okay, so that's the last one for the day. So next class when we meet, we're going to do more problems on vertical circular motion. We'll do some better ones. And then we'll do the power also. So with that, we'll wrap up the chapter next class. And next week, we'll start off with mostly either center of mass or ray optics. I'll let you know. But with this, right, you'll be finishing off your major test ka portion. Right. So I'll send you some practice sheet for your major test also next week. And plus, we have tests also which are based on that, all the chapters that are done. I think if you take them seriously and if you refer the notes, I think your major test will go quite fine. So do start working from that, from that point of view from now. Okay, so we did almost like 33 questions. So do make sure to revise the notes once, especially do today's problems again tomorrow. And the test is online till night 11. So make sure to give it if you have not done so far. Okay, so with that, we'll wrap up for the day. So any doubts, anything, please stay back or else you're free to leave. I'll see you on Friday at the same.